Okay, so this problem is asking us several things about the series capacitor on the right, and it gives us that we have a potential difference of 50 volts, and our C1 value is 12 microfarads, C2 is 4 microfarads, and C3 is 6 microfarads. So series capacitors are characterized by having consistent charge for each capacitor, but different potential differences and different capacitance. So in terms of solving for various things with this series capacitor, we're going to have to keep that in mind, and the equations are catered to that fact. So to find CEQ, the unique equation for a series capacitor is 1 over all the capacitances, that's sum to the power of -1, and then the overarching equation that you use for most capacitors in general is that CEQ equals Q over change potential difference. So we're going to be using all of that to do the charge. So the first thing we want to do is solve for CEQ, which all you have to do is use that equation on the left and plug in the values, and we get a CEQ of 2 microfarads. And I kind of just noted once again that all of those capacitors are actually going to have the same charge, which is going to equal CEQ times change in potential difference. And we can use that more overarching equation because, once again, that charge is consistent for each capacitor. It's going to be the same. So that overarching charge, once you multiply the 2 microfarads by the full 50 volt potential difference the problem gives us, we get that each of those capacitors is charged to 100 microcoulombs. So B is asking about the potential difference across each capacitor. So each of these are going to have different potential differences. And I'm just going to go back really quickly so we can look at the equations. You can see I've already showed that the equation to solve for this is change V1 equals Q over C1, and then change V2 equals Q over C2. And what all of that kind of means also is that once we find all the potential differences, if we were to add those, it would give us back a total potential difference of 50 volts. So that's kind of how these equations are connected. But doing the math, you can see that we use the charge value we saw for in the previous step and then just divide by the capacitance of each of these capacitors. So the first one we get 8.3, second we get 25, and the third we get 17. And if you do that math, you will find that it equals about 50 volts. So yeah, that's pretty much this problem. I think with all of these capacitor problems, the hard thing is kind of establishing which equations are useful and what's going to change and what's not going to change in the system and stuff like that. But once you figure that out, it becomes pretty simple. That's pretty much it. Thank you for listening.